Welcome back to another STEMpower at Home video. My name is Audrey and today we'll be doing the candle vacuum experiment. You're going to need adult supervision to do this experiment, so grab a nearby parent or adult. Before we start, let's review how gases and pressure work. Hopefully you already know that the three states of matter are solids, liquids, and gases. Solids have a definite volume and a definite shape. Liquids have a definite volume and an indefinite shape, and gases have neither a definite volume nor a definite shape. The particles that make up gases move around freely, and their speed increases as temperature increases. The pressure of a gas depends on how frequently the particles bump into each other. And if the gas is in a container, the pressure also depends on how frequently and with how much force the particles bump into and push on the walls of the container. From this information, we know that if you have a gas in a container and you increase the temperature, the gas particles will speed up, causing them to bump into each other and the walls of the container more frequently and with more force. Therefore, the pressure will increase with temperature. Keep these things in mind when we're doing our experiment today. They may help you understand how the candle vacuum works. Now, let's get started. For this experiment, you will need a dish that can hold water, 2 clear glasses, a tea light candle, a lighter or matches, and if you want, food coloring or colored syrup. The food coloring is optional, but it may make it easier to see the experiment. First, fill up one of the glasses with water. If you have food coloring, put some in and mix it. You might need a spoon for this. Take your water and pour enough of it into your dish to have a small layer. Depending on the size of your dish, you may need more or less than 1 cup of water. The exact amount of water doesn't matter for this experiment, so just make your best judgment. Light your candle and put it in the middle of the dish. Please have an adult do this part if possible. When your lit candle is in the water, place your other dry glass over it. Make sure no air can escape, which means you may need to press on the top and hold it. Leave the glass there for a minute or two and observe what happens. Hopefully, the candle should have gone out and the water in the glass should have risen. If this didn't happen for you, pause here, light your candle again, and reset. Once you get the results, come back to the video. Discuss. Why did the candle burn out? Fire needs oxygen to burn. Because the candle was inside the glass, it could only burn through however much oxygen was inside that glass. Once there was no more oxygen, the fire extinguished. Discuss. Do you know what equilibrium means? Can you describe what equilibrium between the pressures of the gases inside and outside the glass is? Equilibrium is a state of physical balance, and the environment prefers this balance. In the context of this experiment, equilibrium would mean that the pressure inside the glass equals the pressure outside the glass. Discuss. Why did the water inside the glass rise after the candle flame extinguished? Try explaining this in terms of gas, pressure, and equilibrium. When the candle was lit inside the glass, it heated up the air inside, causing the gas particles to speed up and increase pressure. Once the candle ran out of oxygen and extinguished, however, the air inside the glass began to cool. Eventually, it cooled to the point where the pressure inside was less than the pressure outside the glass. Because the environment prefers that the gas pressures are in equilibrium, a vacuum is created inside the glass, and the gas pulls the water up and in to increase the pressure until it is equal to the outside pressure. I hope this experiment was fun, and I hope you learned something about gases, pressure, and equilibrium. Comment down below if you enjoyed this video or if you want to share your results. Click here to watch more STEMpower videos and click here to subscribe. Bye everyone!